Good morning, students. I welcome you all to this mathematics class, and today we are going to discuss class 12 mathematics chapter 2 inverse trigonometric functions, and we have already discussed domain and range of inverse functions, and today we are going to discuss properties of inverse trigonometric functions. So now the very first property, as you can see here, is that if y is sine inverse x, then sine y is equal to x. That means if y is sine inverse x, this property implies x is equal to sine y, and conversely also it is true. That means if x is sine y, then also y will be sine inverse x. This is a very first general property of the inverse trigonometric function sine x. Now, this is true. Whatever is true for sin x, this is true for other trigonometric functions also. Now we move to the next property. As you can see, this property is sine of sine inverse x is x. Also, x is belonging to the closed interval -1 to 1. And there is another property which looks similar, but it is entirely different. That is, sine inverse of sine x is also x. But here x should belong to the closed interval -π/2 to π/2. In the first property, you can see that on x, sine inverse function is working upon, and therefore x, this particular x, this one, should be in domain of sine inverse x. And we know that the domain of sine inverse x is -1 to 1 closed interval, and therefore x should belong to this interval for this property, that sine of sine inverse x equal to x, to be true. Now let's move to this one, sine inverse of sine x. Here we see that on x, sine function is working. On the variable x, sine function is working, and therefore x should belong to the domain of sine x. Now, from the knowledge of trigonometric functions, we know that domain of sine x is nothing but -π/2 to and π/2, and therefore for this property to be true, x should belong to the domain of sine function. So domain of sine function after making it 1, 1. Otherwise, we know that the domain of sine function is R, the complete set of real numbers. But as we discussed in our previous video, that how do we make the sine function 1, 1, which was not 1, 1, by restricting its domain to one of the intervals -π/2 to π/2. So now whenever we talk about sine function or cos function, in case of inverse functions, we shall take their domains to be the restricted domains only, and therefore x should belong to its restricted domain -π/2 to π/2. Now let us move to the next property, which is sine inverse of 1 by x is equal to cosec inverse x, where x is greater than or equal to 1 and x is less than or equal to -1. Now students, you must be thinking that how come we have written this, what is the meaning of writing this. So let me explain you how we have written all this and how do we write the domains of these functions. So now, as this property says that x should be between less than or equal to, let us draw the real line. Say this is -1 and this is 1, and x is more than 1. That means x can lie either in this position, 1 or more than 1, or it is -1 or less than 1. You can see this pink portion there x can lie. Now if you see what is the domain of cosec inverse x, the cosec domain of cosec inverse x is this only. Whatever you have marked as in pink color, this is the domain of cosec inverse function. Therefore this x is belonging in the domain of cosec inverse function, because cosec inverse function is not this domain. Now the thing is, you have to verify this 1 by x this should also belong to the domain of sine inverse function. Whenever we are writing x here, this x that I have underlined with blue, this should belong to the domain of cosec inverse function. This 1 by x should belong to the domain of sine inverse function. So my job is to check the domain of sine inverse function. Now because x is less than or equal to minus 1. So if I take 1 by x and so I get this 1 by x has to be greater than or equal to minus 1. And if I take the other one, that x is greater than or equal to 1, that means 1 by x has to be less than or equal to 1. So 1 by x will be less than or equal to 1. Combining these two, we get that 1 by x is greater than or equal to minus 1 and it is less than or equal to 1. This implies that the number 1 by x belongs to the closed interval minus 1 to 1, and you know that domain of sine inverse x is this only. Sine inverse function is defined from minus 1 1 to minus pi by 2 to pi by 2. So you have seen that 1 by x belongs to the domain of sine inverse function. Now students, we are going to prove this property that sine inverse of 1 by x is equal to cosec inverse x. For this, let us assume that cosec inverse x is y. That means x is equal to cosec y. Now taking the reciprocal both sides, so 1 by x is equal to, and what is the reciprocal of cosec x? This is cosec y, it is sine y. So now by the very first property we get sine inverse of 1 by x is equal to y. If sine is working on right hand side, then sine inverse will be working on left hand side. Now equation 1 says that y is cosec inverse x. Equation 2 says that y is sine inverse 1 by x. Therefore, by 1 and 2 we get that cosec inverse x is equal to sine inverse 1 by x. Now let us come to the second property. As you can see, cos inverse 1 by x is sec inverse x, where x is greater than or equal to 1 and x is less than or equal to minus 1. And this is the domain of sec inverse x. As you can check that the domain of secant inverse x is r minus 1, open interval minus 1. So you can see here that this function is, this x is taking the values less than minus 1 or more than plus 1, including 1 and minus 1, which is same as r minus 1. Now you can check students very easily, like in the previous case, that here 1 by x, as I have already proved, that if x is greater than or equal to 1 or x is less than or equal to 1, then 1 by x is between minus 1 to 1, and therefore this 1 by x, this is belonging to the domain of. Now let us move to the next property. Tan inverse of 1 by x is equal to cot inverse of x. Here the domain x greater than 0. Let us try to understand that. Now we know that cot inverse function, its domain is R and its range is closed interval 0 to 1. As well as we know that tan inverse function also, it has got its domain to be R, but its range, it's going to be the open interval minus pi by 2 to pi by 2. Now students, this is the quadrant system. If you take x to be any negative angle, for example, I give you one example. If you take, say, cot inverse of minus root 3, and let us try to find its value. Its value will come out to be, let it be y, minus 1 by root 3 will be cot y. So what should be y? Y should be in second quadrant and y should be pi minus pi by 3, because you know cot is negative in second quadrant. Why? Because otherwise you could have taken it to be minus pi by 3 also, but you cannot take minus pi by 3 because minus pi by 3 will not lie in the principal value range. Therefore, for y to lie in the principal value range, you have to take y to be pi minus pi by 3, which comes out to be 2 pi by 3, and this belongs to the principal value range of say cot inverse function. Now on the other hand, we try to check that if I take tan inverse of minus 1 by root 3, let me find what it comes out to be. Let it is x minus 1 by root 3 will be tan x, and as per the domain and range of tan x, tan inverse x, x has to be minus 32 minus pi by 6, and you can see that the value of tan inverse minus 1 by root 3 is minus pi by 6, whereas the value of cot inverse minus root 3 is 2 pi by 3, and these two values do not match. So if this angle x it becomes negative, then the value of tan inverse 1 by x and cot inverse x, they do not match, because for negative angle may be negative or positive. Cot inverse x is always in first quadrant or second quadrant from 0 to pi. But if the angle is negative, the tan inverse function will be between minus pi by 2 to pi by 2. This is minus pi by 2 and this is pi by 2. You see, this is the positive direction of the angle and this is the negative direction of the angle. So, you can see this in black color. This is the domain of, let me show you in green. This is the range of cot inverse function, and this is the range of tan inverse function, and these two match in first quadrant. That means for positive angles. And if you take the negative angles, cot inverse x moves to the second quadrant, whereas tan inverse x moves to the fourth quadrant. And therefore, we have to take x to be greater than 0 for this particular property to be true. Now students, the next property says that sine inverse of minus x is equal to minus of sine inverse x. Now here also you can check that x is belonging to the domain of sine inverse function. The domain of sine inverse function is from minus 1 to minus 1. So x is either this x or it is this x. They both belong to the interval this given. So now we have to prove this property. For writing its proof, so let us take LHS sine inverse of minus x to be y. Then minus x will be equal to sine y. So x can be written as to be equal to minus sine y. And hence x can also be written as sine of minus y. So we can write sine inverse of x to be equal to minus y. So minus of sine inverse x is equal to 1. Now equation 1 gives you the value of sine inverse of minus x. Equation 2 gives you the value of minus sine inverse x, and they both are true, and hence we prove the first property. And likewise children, you can prove the other two properties also. Now students, let's move to the next property. Cos inverse of minus x is equal to pi minus cos inverse x, where x belongs to the closed interval minus 1 to 1. You know, this is the domain of cos inverse function, and hence x is belonging to this interval only. So now we take the first property and let us try to prove this. The first property is cos inverse of minus x should be equal to pi minus cos inverse of x. Now to prove this, let us assume that let pi minus cos inverse x is equal to y. We have assumed right hand side to be y. That gives me pi minus y is equal to cos inverse x, and that gives me cos of pi minus y is equal to x. Now what is cos of 90 minus theta? Cos of pi minus y means cos of 180 minus theta, which is minus cos y, is equal to x. So I can write cos y to be equal to minus x. So I can write y to be cos inverse of minus x. Now you can compare equations 1 and 2. One says, sorry, this is 1. You can compare equations 1 and 2. And one says that y is pi minus cos inverse x. 2 says that y is cos inverse of minus x. Hence, by 1 and 2, the first property is proved, and likewise in the same manner, we can prove the other two also. Now students, let us move to the next property. Sine inverse x plus cos inverse x is pi by 2, where x is belonging to the closed interval minus 1 to 1. So now here you can see that x is here again belonging to the domain of the sine inverse function and cos inverse function, because domain of both sine inverse also is minus 1 to 1 closed interval, and cos inverse is also minus 1 to 1 closed interval. Therefore we have to see, so we have to understand why this has been given. So in most all the questions of inverse trigonometric function, you should be well versed by their domains. Now let us try to prove this first property. Now the first property says that sine inverse x plus cos inverse x is equal to pi by 2, and x belongs to their domain, which is same. Now to prove this, let us assume that let sine inverse of x is 1. Then students, x will be equal to sine y. But sine y can be written as cos of 90 degree minus 5. Now I can again write it like this. Cos inverse of x is equal to pi by 2 minus 1. And now I can write y is equal to pi by 2 minus cos inverse x. Now if I call this as equation 1 and if I call this as equation 2. Now we compare equations 1 and 2. So what do you get? Equation 1 gives you sine inverse x is the value of y, and equation 2 gives you that pi by 2 minus cos inverse x, this is the value of y, and since both of them are values of y, they should be equal, and this gives you students that sine inverse x plus cos inverse x is equal to pi by 2. This is how you prove your property. Now look at the second property. Tan inverse x plus cot inverse x is pi by 2. It can also be proved exactly in the same manner, where you can check that this domain x belonging to R, this is the common domain of both tan inverse function and cot inverse function. And here in the third case also you can see, you can prove this third identity also in exactly the same manner as we have proved the first one. And mod x greater than or equal to 1, this means x is greater than or equal to plus 1 and x is less than or equal to minus 1, which is the domain of sec inverse function and cosec inverse function. You see, the domain of both secant function and secant inverse and cosecant inverses are minus the open interval minus 1, which is same as x greater than or equal to 1 and x less than or equal to minus 1. Because if from the real line, if you subtract this interval, this open interval, what you are left with? You are left with this portion and this portion of real line, which is same as x greater than or equal to 1 and x less than or equal to minus 1. Now the next property we are doing is property 5. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, and the condition that xy is less than 1, this is a very important condition. So now let us prove this property. Now let us assume that left hand side let tan inverse x is a and tan inverse y is b. Now tan inverse x is a, this implies that x is equal to tan a and tan inverse y equal to b. This implies that y is equal to tan b. Now left hand side becomes a plus b. Now we take the value of tan a plus b, which is equal to tan a plus tan b upon 1 minus tan a tan b using the trigonometric formulas we have done in class 11. Now we can substitute back tan a as x, tan b as y, and we get tan of a plus b is equal to x plus y upon x minus y. Now students, here in this question we have not started with LHS. Actually we have started with the value a plus b and then we have taken the tangent of the angle a plus b. This is how we started the question. We have calculated the value of tangent a plus b. So now the next step is that a plus b should be equal to tan inverse of x plus y upon 1 minus x. Now we substitute back the value of a and b. So let us look back what were the values of a and b. You can see a was tan inverse x and b was tan inverse y. So in place of a, I can write tan inverse x and in place of b, I can write tan inverse of y, which is equal to tan inverse of x plus y upon 1 minus xy with the condition that the product xy is less than 1. The same manner you can prove the second property and also the third property. Now we move to the next property, property 6, that's 2 tan inverse x is equal to sine inverse 2x upon 1 plus x square with the condition that mod x is less than or equal to 1. Mod x is less than or equal to 1 means that x should lie between minus 1 and 1. This means mod x less than or equal to 1 means x is between minus 1 and 1. That is, x belongs to the closed interval minus 1 to 1, which is the domain of sine inverse function. Now, similarly, you can see the other property, second one and third one. So let us first prove the first property. Let us prove this property and we take the right hand side. Right hand side is sine inverse 2x upon 1 plus x square. Now let us substitute x to be tan theta. Here you can note that why I have substituted x to be tan theta and not any other trigonometric ratio, because if you put x to be tan theta, then this expression, this becomes 2 tan theta upon 1 plus tan square theta, which is nothing but sine 2 theta. And therefore, keeping this in mind, that what trigonometric formula we can get, we substitute the value of relevant value of x. So we get the right hand side to become sine inverse 2 tan theta upon 1 plus tan square theta, which is equal to sine inverse sine 2 theta. Now this means this is equal to 2 theta. Now you have to substitute back the value of theta. You had already substituted x to be tan theta. This gives you that tan inverse x comes out to be theta. That means the value of theta is tan inverse x. So I get 2 tan inverse x, which is equal to left hand side. Second part says 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. So we take the right hand side, cos inverse 1 minus x square upon 1 plus x square, and in the right hand side we put x to be tan theta. So what our right hand side becomes is cos inverse 1 minus tan square theta divided by 1 plus tan theta, which is equal to cos inverse cos 2 theta, which comes out to be 2 theta. Now we have to substitute back the value of theta. So you can see, since we substituted x to be tan theta, this implies the value of theta is tan inverse x. So in place of theta, we again substitute back tan inverse x, which is nothing but the left hand side. Now the next property, property 6 part 3 is 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. So here also we take the right hand side, which is tan inverse 2x upon 1 minus x square, and we substitute x to be again tan theta, because we know if we substitute x to be tan theta, then only we are going to get a formula from this expression in the bracket. So the right hand side becomes tan inverse 2 tan theta upon 1 minus tan square theta, which comes out to be tan inverse tan 2 theta, because you can see that's 2 tan theta upon 1 plus 10, 1 minus tan square theta is the formula of tan 2 theta, which is equal to 2 theta. Now because it is assumed that x is tan theta, this implies tan inverse x is equal to theta. So in place of theta, we can write tan inverse x, which is equal to left hand side, and hence the proof. So students, these were all the properties of inverse trigonometric functions that you have to study. Now with this, I end up today's video. Keep revising, and please don't forget to like, share and subscribe this channel.